multiplying. So yesterday you should have learned all about monomials and binomials and polynomials and all that kind of jazz. And today what we're going to do is we're going to start multiplying. And we're going to multiply monomials by polynomials. So it says binomial in the title. We're really going to expand beyond binomials into more than that. But the idea is a monomial by something. Okay? What is a monomial?
When it has only one.
It's like one. It's not like separate by multiply or plus.
Yeah, it's one term. So one term means that there's no additions or subtractions. So it's something like 2x. That would be one term. That would be a monomial because there's no addition or subtraction. What's it mean to be a binomial? It means two terms. So that means you have something like 2x, but then there's a plus or a minus sign, and then there's something else. In this case, we have 2x plus 3. That's a binomial because you have one term right here, that's my 2x, and then the plus sign separates from the next term, which is 3. Yep.
Would it be a trinomial if it's like out of the brackets? So it's kind of hard to explain.
So a trinomial is going to look something like this. You have one term, and then you have another term, and then you have another term. And just every time you're adding a plus or a minus sign, you're just adding another term. We're focusing on monomials, something like that, multiplied by other things. And that's what our goal is today. We're going to start things off with a visual representation of what multiplication looks like. You do not have to be able to do this on a test. Okay? You will not be tested on these types of questions. This is to help some people who sometimes learn by seeing what's actually happening. And we can actually represent math with things. So the question is right here. We're going to talk about that for a second. This represents a monomial times a binomial. There's no multiplication sign in there, though. How do I know that's multiplication?
There's brackets for it.
The brackets mean multiplication. So this is my monomial, 2x. And then there's no symbol in between the 2x and the brackets. That means multiplication.
Website story, please come down to the common area now. That's just the students going to the lady website story. Please come to the common area now.
Fun, guys. So that means multiplication because there's nothing in between it and the brackets. Right? Yeah.
If you multiply like an x with another x, does that make that x?
It does, yeah. And we do that in a couple different ways. We're going to do it right now with something called Algebra Tiles, which I think you probably used mainly in grades 7 and 8. But we do them with just little pictures of Algebra Tiles because we don't have entire class sets. So this monomial 2x can be represented with Algebra Tiles right here. This is 1x, so the long skinny one, and this is 2x because I have two of them. Inside the brackets can be represented as well. So this right here is a binomial, x plus 2. Represented out with Algebra Tiles, that means we have 1x, and then plus 2 little guys. So each one of these represents 1. So that's how you set up the outside of these Algebra Tile questions. You'll notice that some questions are shaded in and some aren't. If it's shaded in, that means it's positive. If it's not shaded in, that means it's negative. So you multiply these together in a picture. You notice that this x, if you brought it over, and you times it by this x, and you brought it over, you create a cross section. It doesn't work very well, okay? It's a shame. It should look like this. And you see how you create a whole section. That would be a big square. And so that's why we have an x times an x is creating an x squared. We went all the way down and all the way across. That's 1x squared. And you're going to do that for all these things. You're going to find all the cross sections where they meet each other. So if I took one little x from here, this guy, and I multiplied it by this blue one up here, that would give me one long thing right there. If you imagine them picturing up on top of each other, how much area would they cover if you did that whole area? That means we have one x there. We're going to have another x there when we multiply across. We're going to have another x squared down here when we go x times an x. And when we go x times a 1, we're going to have another x over here. And another x times a 1, we're going to have an x over here. And all this inside stuff, that represents your solution after you've multiplied your monomial by your binomial. So my solution to this question would be, I have 2x squareds, right, 2 of the big guys. And then I have 4 little x's, and they're all positive, so it's plus 4. That would be my answer after I multiplied my monomial by my binomial, using algebra tiles. Again, these algebra tiles will not be tested. It helps some people visualize what's happening. If algebra tiles are kind of like, what is going on, and it's not your thing, that's all right. We're going to do something else after that'll help you with the multiplication. Example 2. So we're going to try to set this thing up using algebra tiles. Again, we have a monomial times a binomial. So my monomial is negative 2x. I know it's multiplication because it's brackets, and there's nothing in between my term and my brackets. So that means multiply. Yeah.
Is that a positive 3? It can't really be negative.
So that's a good question. We're going to get to the inside in a second. I'll answer that question. Right now, we're just going to set up the negative 2x. I'm going to set it up down the side. Negative, so it's going to be 2 long ones that are both unshaded. So that's negative 1x. That's negative 2x. There's 2 of them now. And now we're going to try to set up our binomial. And Josh brings up a good question. His question was, is that a negative 3 or a minus 3? So if we're talking about it like in lingo, I would say it's minus a 3. I'd say that's negative x, and then subtract 3. With algebra tiles, you still represent it as a negative 3. So you would still represent it with 3 negative tiles. But that's a very good question.
Kyle Harbage, can you come to the office, please? Kyle Harbage to the office. Thank you.
So if we were to set this up, that would be my negative x. And then I would have 3 of these guys. 1, 2, and 3. Down the side, I have my negative 2x right here. Negative 2x. Across the top, I have my negative x, and then my minus 3. Now I have to figure out what happens when these things combine with each other. So if I had a long skinny x and a long skinny x, and they met up in the middle in the cross section, they would create a big x squared. Would it be negative, or would it be positive? I hear a lot of people saying positive. Why would it be positive? Yeah, Ken was right. So if you multiply a negative by a negative, it creates a positive. If you do a positive and a positive, it's a positive. Negative and a negative, it's a positive. And then if you do opposites, then it's a negative. So if you have a negative and a positive, or a positive and a negative, that would be a negative. Again, if I look at my cross section, so I have a long skinny one here, and I have a single one there, that's going to create one more long skinny one, and it's going to be positive, because it was a negative and a negative. And that's going to happen 3 times. Now I move on to my next little cross section. So again, I have a long skinny one down here. It's going to cross with this guy up here to create a big X squared. And then you're going to have, again, 3 little ones. The inside of this little area diagram we've made, this little algebra tile thing, the inside is your answer. So how many x squares do I have in the middle there? So I have 2x squared. How many x's do I have? A lot more. How many x's do I have? At least something. Okay, so I do have 6 long, skinny x algebra tiles. Some people are slowly catching. Okay, so we got 6 of them there. Are they positive or negative? They're positive, so it'd be plus 6x. That would be my solution. That's my answer. Okay. Algebra tiles can also be useful for recognizing that you can do things 2 different ways. Like you can get the same answer by multiplying different things. So for instance, right here we have 2 answers, right? They're the exact same. It's 2x squared negative 6x. So you don't have to always have the same thing to get the same answer. And it's kind of confusing. So what I mean is if I wanted to get this answer right here, this 2x squared and then 6 negative x's. I can do 2 negative x's on top. Right, that would work. So that down the side, if I wanted to create a positive x squared, I would need a negative x there. And if I wanted to create all these little negative x's, what would I need to be multiplying by? Yeah. Oh, there. Yeah, go ahead. A bunch of little positive ones. And you see how those outsides would create this inside. This would represent negative 2x. This would be negative x plus 3. So it could look like this. That's not the only way I could create that inside, though. I could create that same inside by doing positive x's across the top. So that would be positive 2x. What would I have to put on the side right here to create that positive x squared? A positive x to create these x squares in the middle, and then 3 negative 1s would create all those negatives. So that would be a positive x and a negative 3. And you see, you don't have to have the same monomial and binomial multiplying together to get the same answer. Those are different. Very close, but they are slightly different, right? The positives and the negatives are kind of swapped around each other. Yeah?
Does it matter if like the top or the left side goes
That's a good question. It doesn't matter. So in this case, I put the binomial down the side, right? And the monomial across the top. If you look back at the other questions, I reversed it. I had my monomial down the side, and I had my binomial across the top. So it doesn't matter which one you choose. In the future, we do area diagrams, but not pictorially. So the same situation will apply then. It won't matter whether you go side or top. I try to keep it consistent, but it really does make a difference. All right, again, those are algebra tiles. My hope for showing you those algebra tiles is that somebody in the room prefers the algebra tiles and help them learn. And that's the hope. what you do have to be able to do on a test is this slide right here. And this is called distribution. So when we multiply, we don't usually, well, first off, we don't have time to use algebra tiles for every question, right? It's a very time-consuming process. The second thing is we don't have ways to represent certain things. For instance, we don't have ways to represent x to the power of 3 with an algebra tile. Like you can do a cube maybe. And we don't have ways to do x to the power of 4 with an algebra tile. So there's certain problems and limitations to using algebra tiles for everything. So instead, we learned something called distribution, or the distributive property. The way that that works is when you have a question where you're multiplying polynomials. So if you look at question A, I have a monomial, 3x, times a binomial, 4x minus. I can multiply those together by doing distribution, which means I take my monomial, 3x, and I multiply it to both terms. So I'm going to go 3x times 4x. And I'm going to think about what that x is. So 3x times 4x. And when you're multiplying things together, I have a rule. I say numbers go with numbers and letters go with letters. Right? So we learned that last unit. So the 3 and the 4 would multiply together. That's 3 times 4. 12. And then x goes with x. Letters go with letters. X squared. So that would be the first distribution. So that was the first time 3x came into the brackets. The next time it comes into the brackets, it has to multiply by the next term, which is negative 7. So now I'm doing 3x times negative 7. Same rules apply. Numbers go with numbers. So 3 times negative 7 would be negative 21. And then x, is there any other x's to multiply by? Nope, so it's still just x. That's my solution, and that's the distributive property. It is something you have to be able to do. You must be able to distribute monomials into brackets. All right, let's see it again. So, question B. I have a monomial. It's kind of a crazy monomial, but it's still a monomial. The reason it's still monomial is it doesn't have any plus or minus symbols. And I'm multiplying it, because there's something in brackets next to it, by this binomial. So imagine trying to represent that with algebra tiles. Right? There's no way you could do that. That'd be crazy. So I'm going to distribute the monomial in to the brackets. So I take this monomial and I multiply it by the first term. When I do that, numbers go with numbers. 4 times 2 will give me 8. The x's go with x's. So x times x would give me x squared. I add the exponents. The z's go with z's. So z to the power of 3 times z to the power of 1 would be z to the power of 4. You add the exponents. That's the first distribution in. Now you need to do a second distribution. And then you follow the same rules. Numbers with numbers, letters with letters. So 4 times negative 8 would give me negative 32. X times x to the power of 5 would give me x to the power of 6. You add the exponents. Z to the power of 3 times y to the power of 4. Perfect answer. Can't do it because they're different letters, right? So different letters can't go together. So you can't multiply this z with that y. So they just stay the same. Y to the 4, Z to the 3.
Where do you get the 33 from?
The 32 came from 4 times negative 8. So good question. So we look at this, right? We did our distribution. And now, do we have any more multiplication? Is there any more brackets or multiplication signs? No, so this is done with multiplication. Now the instinct is to want to start combining letters, right? Because I have Z to the 4, Z to the 3, I have some X's in here. The problem is, these are not like terms. Remember, like terms can be combined. And a like term means you have all the same letters and all the same exponents. This is one term. It has an x squared and a z to the 4. This is a second term. It has an x, a y, and a z. These are not like terms, so they cannot be combined. That is your answer. Things that can be combined, so this has nothing to do with this question. If I had something like 4x squared y minus 2x squared y. Those would be like terms, because they're both x squared y. That answer the question? Okay. You have to have the exact same letters and the exact same exponents to be able to combine it. Yep.
So for question C, are we doing something like that?
So for C, we're going to have, it's going to be a little different, and we are going to follow bedmaps. That's exactly what you're going to do. Yeah. Perfect. Yeah, all three of you are right. So you said we're going to do bedmass. You're going to distribute a property twice. You're going to multiply and multiply. All three of you said the same thing, just different ways. So if you see a big question like this, all it would say on your test is simplify. Okay, so try to write that out as one big equation. That means you're going to have to multiply things. And you're going to have to follow bedmaps. So you're going to look at your brackets. There's nothing in your brackets you can do. There's no exponents to do. There's no division to do. But there is some multiplication to do. You have a monomial brackets with a binomial. So it needs to distribute in. The first distribution, I'm going to color code these. So the first distribution that comes in, you have 4x times 3x, numbers with numbers, letters with letters. That'll be 12x squared. My second distribution, that 4x multiplies to the negative 8. So 4 times negative 8 gives me negative 32. And then x. And notice that the brackets are now gone. Wait, okay. That's the first monomial times the binomial. Now we have to do it again because there's another set of brackets over here. When we do that one, your term is not 3x. It's negative 3x. Remember, negatives come into brackets when they're to the right of them. So this negative 3 has to multiply to the first thing. So negative 3x times x would be negative 3x squared. And then that negative 3x times negative 7, so it distributes all the way to the next one, which can be positive 21, so we represent that with a plus sign. And then x. Definitely. So we did our multiplication, right? We are following bedmass. And we're done all of our distribution. Does anyone have any questions about the distribution? Alright. We have a good suggestion. And the suggestion now is if you continue with bedmass, you have to try to do any additions or subtractions you can do. This is a situation where you have like terms. you have x squared and x squared. Like terms can be added and subtracted. So if I have 12x squares and I have minus 3x squares, I have 9x squares left. Notice it's not just 9, it's 9x squared. I have another like term. I have negative 32 and plus 21, and they both have an x with them. So negative 32x plus 21x would give me negative 11x. The way I'm calculating that is in my calculator, I just went negative 32 plus 21, and that tells me negative 11 is how many x's I'm left with. That's what I can put in my calculator to figure out how many x's I have. Your calculator, you can't put the x in.
Yeah, since it's a like term, wouldn't she be adding your
See, and that's the same question I think Ali had on this one. Was now that you're here, what do? Can you combine those x's to become x to the power of 3? And the answer is no. And the answer is no because it's not multiplication anymore. These are separated with a subtraction sign. So you can't combine these x's or these exponents because this is subtraction. You only combine letters with different exponents when you're doing multiplication or division. And that's where a lot of people get mixed up. They try to combine one more time, and you can't. Yeah. Yeah, it's an x or an x. They're different, right? So you can't combine them. All right. For D, I want you to try to distribute that yourself. Actually, try to do the whole question. So see if you can get to the point where you're happy with your answer. You might have to combine like terms. You might not have to combine like terms. Okay, so give it a shot. Try to distribute. Try to multiply. See what you get. I look at a question like this, and the first thing I do is I recognize I have a monomial times, because of the brackets, and then this is a polynomial, right? That's 4 terms all separated out. My strategy is still the same. Monomials times any amount of terms just need to be distributed in. So that 2x has to be multiplied by the first term. Numbers go with numbers, so 2 times negative 4 is negative 8. X times x cubed, you add the exponents, become x to the power of 4. Make sure you add the exponents. Make sure you have negative 8. That's the first distribution. I have to distribute again. So 2x times 7x squared. 2 times 7 is going to give me positive 14, so I go plus 14. X times x squared is going to be x. Notice it's x cubed, so check your exponent. The other thing is make sure that you have a plus sign in there. So if I have a positive number, I put a plus sign. If it turns out to be a negative number, it would have been a subtraction. Now I distribute again. 2 times negative 3 is negative 6. Make sure you have a negative. X times x is x squared. The final one, 2x times positive 8 should be plus 16. At this stage, and sometimes in math, the hardest thing is knowing when to stop. When can I stop doing things? The way I know I can stop is I have no more brackets. They went away when I distributed it. And I have no like terms. All my letters are different, or all my exponents are different. Right? I have an exponent 4, an exponent 3, exponent 2, exponent 1. That means I'm done. This is my answer. No light curve there. Okay, so you have plenty of time